Bismillahirrahmanirrahim. In this lecture, we will study about Boolean algebra. The foundation of Boolean algebra starts with the set B, which consists of two elements 0 and 1. So a Boolean variable is a variable whose value belongs to this set, right? Like we have already studied real algebra, we studied of some variable x which have some real values. Similarly, a variable is called Boolean variable if it can have only two values, 0 or 1. And on a similar note, like real valued function, which we used to study f from R to R, here we have Boolean function, which f is from the set of Boolean to the set of Boolean. And why here we are taking the power n? Because the f may have more than one variable. So f is a Boolean function, and f may consist of two variables or three variables. So in general, a Boolean function represent the output of some circuit or some compound proposition. And when we talk about compound proposition, it definitely have more than one variable. So f of x, y, z can be any function of three variable like x, y plus z. So this is the Boolean function of three variables, and here x, y, and z all are Boolean variables which may have values either 0 or 1. So as you know that Boolean algebra is basically the structure algebra, and the structure algebra starts with a set. As we have seen that the Boolean algebra depends upon the set B, which is called the set of Boolean, and we have defined two operations on this set, the plus and dot. The plus refers to the OR operation or the disjunction, which we have studied with the propositional logic, and dot used in place of and or conjunction. And this complement, like we write x complement instead of the negation p, like we have used to take negation of some proposition p. And the algebra is such a structure which satisfies certain properties. So this algebra satisfies closure property with respect to or, and the closure property with respect to dot. And then we have the identity element 0 and 1, as we have discussed in the previous class, that the 0 is the identity element of the disjunction or plus, and 0 and the contradiction is the same thing. And 1 or tautology is the unit property or the unit element of the dot. Similarly, there are certain other properties like commutative law, distributive law, etc. So together, this set together with these operations and these properties is called Boolean algebra. Now, a Boolean function is any compound proposition. So if we write p in place of x, and we write q in place of y, and r in place of z, then this, in the propositional logic, we can write this proposition as this. And as you see that this is a compound proposition, which is a combination of the three propositions P, Q, and R. So similarly, any proposition that we say in our natural language or English language can be translated as a Boolean function, and we can refer to as the output of some digital circuit. Also, this Boolean function can be represented not only through this functional expression, but also through the truth table. So as you know that we all already studied that how to make truth table. So similar manner, we can construct the truth table of this function by using first the columns of input variable, and then one column for the summing it, and one column is taking the negation of z, and then the last column will be join of these two propositions. And by using these many columns, we can construct the truth table of this function, which is already given here. So here you can see that the function has three ones in the output, which shows that at three set of input functional value, we have the output is equals to 1. So this is also this also shows the working of this function as a Boolean circuit. So let's suppose we have a x value and y value and z value. Then these two variables are joined with the OR operator like this. And then this, after taking the inversion, join with these with the help of AND gate. So the output of this is x plus y, negation or complement of z, and this becomes x plus y into z prime. So this is already what we know, that the plus is the similar as OR, dot is similar to and this complement is similar to the NOT operator. The next thing is the definition of literals and minterm. So a literal is a Boolean variable or its complement. So what does this mean? That in the expression of the function f, if we have some Boolean variable x, or its complement is present. So we say that this is a literal and this is also a literal. Similarly, if we have a three variable function of x, y, and z, then the literals would be these six. So either the function can be written in the form of x, x bar, y bar, or z, z bar. So the function can be written in the combination of only these six literals. So all the possible variables which will be used in writing that function is called a literal. Now, what is a minterm? Minterm is the product of these literals. So, what is the rule of making a minterm? In a minterm, every variable must contribute. So, if a function is of three variable function, then its minterm must contain all the representation of all the three variables. Either the variable itself is there or its complement is there. But in every minterm, each literal must be present. So if we have the Boolean function of n variables, then every minterm have n literals in it. And what does minterm represent? Minterm represent the one value or the one output of the function in the truth table. So we will see this with the help of an example of the same function that we have just considered before. Here you see that this function has output 1 in the 3 of the rows. So these 3 positions are enough to describe the function. So if we see here, then we see that the x variable has the value 0, y has value 1, and z has value 0. So this 0 value of x is represented by x bar, the 1 value of y is represented by y, and the 0 value of z is represented by z bar. Similarly, against this one, we have x and the complement of y and the complement of z. Similarly, for this one, we have x, y, and z bar. So this function can be represented with the help of these three minterms, and these three minterms are enough to describe the function. And why this is called minterm? Again, as I say, the function is of three variable function, and this is a product terms of the three literal. So therefore, this is called a minterm. So the next is sum of product expansion. The sum of product expansion is the sum of all the minterms. So as you've seen in this example, that this is the sum, these are the minterms in which we can represent a function. So if we write the function, we can write this function as a sum of these three minterms. So we write the function as x, y, z bar plus x, y bar, z bar plus x, y, z bar.